really crucial if you want to get, say, full marks on these types of questions we're going to be working on today and tomorrow. However, I do understand there's limitations to people's abilities, and some of this is going to get really taxing on the brain, so I will be teaching you a way we can just get the answers, but it's less of an understanding. Okay? So we're going to be solving absolute value equations graphically, and we're also going to be solving them algebraically. Does anybody remember what an extraneous solution is? Or an extraneous root? Jay, you want to give it a shot?
Answers that don't work in the equation.
It's a solution that doesn't work in the equation. That's true. Is it just some random number you've picked and, oh, it doesn't work, so that's not the answer?
No, it's one you get based on your square root or radical.
Right. So, and you're thinking of radical equations. The bottom line is you do everything right. You square both sides to get rid of a radical, and it leads you to an answer or to a solution, but the solution is just not working. In a more general sense, that's an extraneous root of a radical equation. An extraneous root of an equation is a solution to an equation that you get by doing things right, but it's just wrong. This morning we were doing logarithmic equations, solving logarithmic equations in Math 30. We had extraneous roots. Very often you get solutions that just don't work, even though you've done nothing wrong. So, when solving absolute value equations, the absolute value part of the equation must be rewritten in piecewise fashion. It's not like you can get rid of a square root by squaring both sides. You can't get rid of an absolute value sign by doing something. You have to change the question. And what this means, everybody, is that you're going to get two equations. Remember what we were just talking about? You take a function and it turns into two functions without absolute values? Well, you're going to take an equation and you're going to turn it into two equations. One of the equations will just be whatever the original equation was, but you just ignore the absolute value signs because they were not needed. One of the equations, in other words, is simply going to be solving the equation without the absolute value signs. One of the equations is not going to be that. It's going to be a different equation that we have to create if what's inside the absolute value is negative. Because if what's inside is negative, when we remove the absolute values, we have to multiply it by -1 to make it positive. Okay? So let's put this into action. We're going to dive right in with an example here. What is the solution to this equation? Well, would you agree that potentially speaking, this is the equation that we would want to solve if the absolute value signs were not needed? Okay? This? What would the equation be? And we're not going to do this every time, but I actually want to write this. The absolute value signs are not needed. By the way, if they're not needed, you know what that means? It means 2x plus 3 is positive. Or 0. Right? This is saying that 2x plus 3 was greater than or equal to 0. No, we don't know whether it is or not because we don't know what x is. And I get that that's a confusing idea. But if 2x plus 3 is greater than or equal to 0, then we just don't need the absolute value signs. Okay? What would the other equation be that might have a solution? And I'll start here with actually giving you this part. What if the absolute value signs are needed. Well, listen, if the absolute value signs are needed, you know what I'm telling you? I'm telling you that 2x plus 3 is less than 0. I'm telling you that it's negative. So what would that equation change into if 2x plus 3 was a negative thing? You want to give it a shot, Jay?
Times it by -1.
Yeah. Negative 1 times 2x plus 3 equals 8. I hope you understand that all we've done is we've broken a function of x, the absolute value of 2x plus 3, into pieces, right? And I'm now on a path where I'm going to show you how we can get the answers here without you understanding the perfect solution, okay? Can you solve both of these equations? Well, geez, I sure hope so. 2x plus 3 equals 8 is a pretty easy equation to solve, isn't it? I like to call this, I just get in the habit of doing this all the time, I like to call this equation 1 and this equation 2. Okay? We're always going to get two equations to solve. So for equation 1, what are we going to have? We're going to have 2x plus 3 equals 8. That means 2x equals 5. So x equals 5 over 2. Am I right? Pretty straightforward. Okay. What about equation 2? Well, with equation 2, we've got negative 2x minus 3. I've taken the liberty here of multiplying that negative through. Equals 8, which means negative 2x, which means negative 2x is equal to 11. And what does that tell me? That tells me that x is equal to negative 11 halves. You're still with me? Okay. So let me highlight those two solutions and do one more thing, and then I have something that I would like you to do. Here's one of the solutions that we're getting. Here's the other solution that we're getting. And what I want to do is write down the original equation here. You don't need to write it down because you can see it on your work there. The original equation is the absolute value of 2x plus 3 is equal to 8. What your job is right now is to put in 5 halves in for x and see if it works. See if you get a true statement. In other words, see if the absolute value of 2x plus 3 does give you 8 when x is 5 halves. I think so. 2 times 5 halves is 5. 5 plus 3 is 8. The absolute value of 8 is 8. So this has the proper outcome, which means x equals 5 halves is in fact a solution. What about when we put negative 11 halves in there? Well, again, this is your job. I'm not going to write this down for you. You're going to put negative 11 halves in there and see what happens. Does it work? You're going to take 2 times negative 11 over 2. I'll give you a negative 11. Plus 3 is negative 8. Absolute value of negative 8 is 8. That works. Okay. So you're done. I don't think that's worth full marks, though. Because what you really want to be able to do is demonstrate to me that those are the solutions because they're in the proper domain. So I'm going to go back now and talk about this bit of business here where it says the absolute value signs are not needed because 2x plus 3 is greater than or equal to 0. Well, if 2x plus 3, everybody, is greater than or equal to 0, then 2x is greater than or equal to negative 3, which means x is greater than or equal to negative 3 halves. Are you with me on that? Okay. This equation, everybody, and this is getting very subtle, this equation is only valid in that region for x. On a number line, x is greater than or equal to negative 3 halves is this. Correct? Look at the answer we got from that equation, 5 over 2. Is 5 over 2 in this domain? Yes, because 5 over 2 is a positive number. It's obviously bigger than negatives, and that's why that's a solution. You shouldn't need to put it into the equation to check it. So a student who does this, that we did originally, and then they actually show their work of putting 5 halves in here, I'm saying that's not good enough for 5 out of 5 if it were an assignment, or for 3 out of 3. I'm saying doing this instead, and then saying 5 halves is in here, yes, it's a solution, that's worth the marks. What about down here where 2x plus 3 is less than 0? Well, that means 2x is less than negative 3, x is less than negative 3 over 2, which, I mean, you're going to start to see the point here. For this one, I'm going to use a different color. For this one, it's that, right? It's the rest of it. If the first equation is for when x is bigger than or equal to 3, negative 3 halves, then the other one is everywhere else. Now look at this x value of negative 11 halves. This statement is only valid for this equation. What did this equation yield? It yielded negative 11 halves. Is negative 11 halves in this region I've marked with the blue line on my number line? Yes, that's what makes it a correct solution. All right, let's move on. Let's try another one. So this one we're going to do properly. We're not just going to break it into 2 equations. We're going to find those subdomains first. One of our equations, though, I mean, we are going to break it into 2 equations, will be 2x minus 8 minus 2 equals 4x. And this will be where 2x minus 8 is greater than or equal to 0. Right? Leave some space there because that's not what we write. Our second equation is going to be negative 1 times 2x minus 8 minus 2 equals 4x. And that equation is only going to be valid where 2x minus 8 is negative. Well, let's solve this for x. Let's take this inequality of 2x minus 8 and solve it for x. I want everybody to rearrange it for x. It's a 2-step linear inequality. You're going to add 8 and divide by 2. And I hope that you see you're going to get x is greater than or equal to 4. Are you on board with that? Yeah? What will the other inequality be? What will this inequality be, Christy, when we rearrange it for x?
The x is greater than
Smaller than 4, perfect. X is smaller than 4. And we could either arrive at that by rearranging this inequality or just saying if x is greater than or equal to 4 for one, it must be x is less than 4 for the other. All we do now is you solve each of these equations, and if the number you get is in the proper subdomain for x, it's correct. If the number you get is not, it's not correct and it's extraneous. So when I solve this equation, this is pretty easy. I'm going to subtract 2x from both sides and get 2x equals negative 10. Would you agree? Don't just, be a passive learner here. That's not learning. Think about things. So what does that yield? That yields x equals negative 5. Is negative 5 in this domain of x is greater than or equal to 4? No. If you need to draw a number line, I think that conveys a lot of useful information. You don't always need to draw it, but if you need to help you wrap your head around whether the number is in there or not, do so. This is not a solution. On an exam, you'd write, well, it's not a solution because it's in the wrong domain. By the way, if you were to put negative 5 up there, it just wouldn't work. Okay? If I put negative 5 in here, I get negative 10 minus 8, which is negative 18. The absolute value of negative 18 is 18. 18 minus 2 is 16. Remember that, 16. If I put negative 5 here, 4 times negative 5 is negative 20. It's not 16. Okay? When I solve this equation, this one requires just an extra step because I got to multiply this through. I get negative 2x plus 8 equals 4x. Oh, minus 2. I move the 2x over. This time I get 6x and I get 6, so x is equal to 1. Is 1 for x in the domain for this equation we just solved? Yeah, because it's x is less than 4. That means that is a solution. And if you want, you can put 1 up there for x and convince yourself that you're going to get a true statement. But you don't need to. So, again, if you just did this and checked to see whether they were correct or not, and did not have this, you're not going to get full marks. All right. Well, again, one of your equations, it's equation 1, will be 2 minus 2x minus 1 equals 4 minus x. What have I done wrong? Intentionally this time? Right, I forgot the brackets around the 2x minus 1. And let's, get used to this idea. You need to take that argument of the absolute value and solve this inequality. You need to do it every time. And that turns into x is greater than or equal to a half. I don't think that's any great mathematical feat, rearranging that. You're all with me on that? So that means it's this equation when x is greater than or equal to a half, which means, everybody, the second equation, which will be 2 minus, oh man, I just want to change that minus to a plus. But I'm going to go minus negative 1 times 2x minus 1. Remember, one of your equations, you just lop off the absolute value signs. One of the equations, you get rid of them and change what's inside by multiplying by negative 1. Equals 4 minus x. This second equation is automatically the opposite domain. We don't need to re-solve a different inequality. So we solve each of these. Not sure why stayed on green there, but that's okay. This is 2 minus 2x plus 1 equals 4 minus x. I have to multiply this negative through. This gives me x equals, I add 2x to both sides. I move that negative 2x over, it becomes positive 2x. And then I have 2 plus 1 and then minus 4 by my count, and I need my confidence boosted here by you checking to make sure that you agree with me that you get x equals negative 1. Good. Is negative 1 in this domain? Is negative 1 a number that's greater than or equal to a half? Nope. Not a solution. You don't need to put it into the equation to check. It will not be a solution because it's not in the right domain. Solving this other one, geez, I really hope that you see that a wise mathematical move here would be to just do this. Subtracting negative 1 times something, which means you're adding it. So this becomes 2 plus 2x minus 1 equals 4 minus x. This becomes 3x equals 2. Nope. Equals 3. So x equals 1. Take a minute and go through all of the motions there and make sure that you agree with that. I add x to both sides to get 3x on the left. The 2 minus the 1 is 1. I subtract it away from 4, giving me 3. So 3x equals 3, x equals 1. Is that in the domain for that equation? No. Wow. This equation has no solutions. Let's keep going. One of your equations will be 3 minus x is equal to 2x minus 1, or plus 1 rather. I'm going to do these side by side this time. One of your equations will be negative 1 times 3 minus x equals 2x plus 1. We need to solve this inequality. And I'm going to give everybody a minute to do so. I want you to do this. I want a statement about x. I want to see something like x is greater than or equal to something, or x is less than or equal to something. But you need to solve that equation. Sorry, that inequality is what I should call it. I would prefer to move the x over, but what that means is that x is less than or equal to 3. Because if 3 is greater than or equal to x, x is less than or equal to 3. And I'm including this example here to illustrate to you that the one equation where the absolute value signs are just erased is not always where x is greater than or equal to something. It could be where x is less than or equal to something. This, of course, will be the opposite. And then you solve these. I mean, I'm sensing maybe it's the heat, maybe it's starting to get warm and you guys are tired or something. I'm sensing kind of a flatness today from you. Is that, am I getting the right psychic vibe here? That's how you guys feel? Wish I had my juggling balls or bowling pins I could juggle for you and try to wake you up. Solve this equation for me, please. 3 minus x equals 2x plus 1. And the reason why I'm sensing this is You know, I've been asking you to kind of do some of this on your own, and I just look out over a sea of dead eyes this afternoon for some reason. I'm getting 2/3. Can anybody agree with that? Okay. Is 2/3 a number that is less than or equal to 3? Definitely. It's a solution. We do the same thing here. Again, with the -1, you have an additional step. You have to multiply that through. So we get -3 plus x equals 2x plus 1. Subtract x from both sides, subtract 1 from both sides. I'm getting -4. And anybody want to think about that and agree? You're good with that? Okay. Is -4 in this subdomain where x has to be greater than 3? No. That means that is not a solution. There's only one solution. I think you get the point. We can move on past number 5. Let's take a look at number 6, though, and this is not going to take long at all. We're not even going to do anything on paper. We're going to remind ourselves, this is just such a valuable thing that students forget. You can solve any equation on your graphing calculator, right? I can put, and I'm not an x-intercept fan when it comes to solving equations. I can put this for y1 and this for y2, and of course we're interested in where they're equal, so it's where they intersect. Where being the optimal word. Where meaning xy's. So y equals the absolute value. We go to our math menu. You scroll over to the number submenu and you do that. Depending on your calculator and the mode you may find yourself in. Did anybody's calculator just spit out ABS? Okay. So that means you're either in the classic mode or you have a TI-83. It doesn't matter. If you are not in the classic mode, you're in the math print mode, you see this. So then we go 2x plus 5. And if you're in that mode I'm in, you got to use the arrow to get out of there. If you wanted to type something else, and then 3. Let's go zoom standard, zoom 6. There's an absolute value function. There's the graph. Let's just a second here. If I go back and I look at example 1, oh, it was a different question. But we could have done example 1 that way. Anyway, there are 2 solutions, just like in example 1. Where do they happen? Well, you go to your calculate menu, choose intersect, enter. Well, I'm close to that one on the right, so I'm just going to hit enter 3 times right now. That's where my cursor is located. -1. -1 is a solution. Repeat. By the way, if you ever find yourself scrolling and you're on the graph that's taking you all over the place, just hit the up or down arrows and it will switch to the other graph and you can go quicker. -4. So the 2 solutions here are x equals -1, x equals -4. If you were to do what we did for all of the other examples, both of the solutions you would get, the one for each equation, would be in their respective subdomains. Okay? Question?
For my calculator, when I put in numbers, it says there's an error with it. Then it goes to.
So maybe.
Oh.
And I only knew that was happening because it was able to graph both of them, and then there was a pause, so there was something else typed way down there.
Okay.
Yeah,
Thank you.
you're welcome. Let's try this one. Is this one of the ones that we just did? It is? I thought it looked recognizable. What did we get for solutions here? I want to go back and just look at this. We got for that one, is that this one? No. Was it one we just did? Number 4, okay. We got for solutions 2/3 and -4. And -4 wasn't correct, right? Okay, watch what happens when we do that now on our calculator. So we're going to have the absolute value of 3 minus x. I got to delete something out of there now. And we have equals 2x plus 1. Graph. Do you see that that line, the straight line, not the V, is an angle that's only going to intersect in one place? It's not going to intersect anywhere else? Well, let's find out where it intersects. Two-thirds. And that extraneous root of -4 doesn't even appear on there. But you need to be careful, because I will on exams sometimes say, when you solve this equation, what is the value of the extraneous root? And you can't do it on your calculator then. One more, let's just do this one. I would say that this one, it would be a challenge question for you to do algebraically. And there's at least one in your handout that is a challenge question. It's got 2 absolute value signs. So I'm going to put the absolute value of 2x minus 3, get out of there, and then minus another absolute value of x plus 4. And that's equal to 8. Let's see what happens. An absolute value minus an absolute value, the v becomes all skewed, and it's no longer touching the x-axis. How many solutions will this have? We'll have 2, right? We can only see one, but you can see that they're going to intersect further down the road. Let's find the one that we can see first. -3. I didn't write down my answers for B, I apologize. I'm going to go to my window setting and go up to 25. I need to look further in that direction. 25 seems like a reasonable number. Let's see what happens here. Yeah, I think that'll do it. And 15. I forgot that first one. Was it -3? So -3 and 15. But, you know, I keep throwing this solving equations graphically your way to remind you, if you're stuck on an exam, I mean, you're allowed to use these calculators. Any equation, trigonometric. Don't think everything has to be done on paper. The thing you need to know, though, of course, is I could ask you to do it on paper for a 25% weighted question. I put up here page 389, 2, 4, and 5. I don't know that that's necessary. I think on yours, I think I just said the additional questions on page 24 of your handout. I would say that's good enough. Be careful with 2. Don't do 2C or D. Why? Why do you think I don't want you doing C and D? Yeah, they're going to be quadratic. So when you have an absolute value equation, you get 2 solutions. If you have a quadratic one, you're going to get 4 solutions because you'll have 2 quadratics. And I think there is a challenge. Is there a challenge question on that page? Yep. That's the one with 2 absolute values. If you want, you can see if you can wrap your head around what to do there. Okay. Yeah, that's it. Get to work on those, please. You've only got about 10 minutes left, but the 10 minutes is enough to get started quickly, yeah.